Hi guys, welcome to my channel. In this video, I will be covering complete unit 5 in PPS. I will explain each and every topic in detail. If you are watching this video for the first time, don't forget to like, share and subscribe to my channel. And guys, I have uploaded complete PPS subject tutorials. I will provide link in description, you can watch from there. I also provided study material link in description. You can download from there. Let's get started. At first, I will explain what is an algorithm and what are the characteristics of an algorithm. An algorithm is a step-by-step procedure to complete a task. Is known as algorithm. It is not like you are using algorithms only in computers. You are also using algorithms in your real life. For example, I want to make coffee. What I do is, at first in step 1, I will take a pan and I will add milk in it. After that, in step 2, I will switch on the gas stove, and in step 3, I will add sugar and coffee powder. In step 4, I will boil it, and at last in step 5, my task gets completed. That is, my coffee is ready. Here my task is to make coffee. So I followed sequence of steps in order to make coffee. This is known as algorithm. An algorithm is step-by-step procedure for solving problem or to complete a task is known as algorithm. Next, you need to know what is meaning of pseudocode. Pseudocode is an informal and artificial language that helps programmers to develop an algorithm. Informal means user-friendly language. Artificial language means man-made language. Language which is created by human beings is known as artificial language. So, algorithm which is written in English-like language is known as pseudocode. Whatever the algorithm that we are writing in English-like language is known as pseudocode. There is no proper rule to be followed in order to write an algorithm. So, you can write algorithm as your wish. This is an example. Here I am writing algorithm for addition of two numbers. Step 1. Always step 1 is start, because I am starting algorithm. And in step 2, I am reading two values. After reading two values, in step 3, I need to add these two values. After adding two values, in step 4, I need to store this result in another variable. And at last in step 5, I need to print variable that contains result. And at last step 6 is stop. This is how we need to write algorithm. There is no proper rule that we need to follow in order to write an algorithm. So you can also write this same algorithm like this. Step 1 is start. And in step 2, I am reading two values, that is A and B. After reading two values A, B, I need to add these two values and I need to store this result in another variable C, and I need to print this C because it contains result, and at last step 6 is stop. This is how we need to write algorithm. There is no rule that you need to write algorithm only like this. You can write algorithm as you wish. Here I written same algorithm like this. Here this is another example. Here I am writing algorithm for average of 3 numbers. Step 1 is start, and in step 2 I am reading 3 values. I am assuming values as A, B and C. And step 3 is sum A, B, C. That means I am adding A, B, C values. After adding, in step 4, divide sum by 3. And in step 5, I am storing result in another variable, that is variable D. I am storing this result in variable D, and in step 6 I am printing variable D because variable D contains result. So I am printing variable D in step 6, and in step 7 stop. Now, or you can also write end program. This is how we need to write algorithms. These are the properties which we need to follow before writing an algorithm. These are the characteristics. You can also say this as characteristics of algorithm. First one is input and output, and second one is finiteness, third one is definiteness. You can also say definiteness as unambiguous, fourth one is effectiveness, and at last fifth one is generality. First one is input and output. Each algorithm must take 0, 1 or more quantities as input and should produce at least one output. For example, in this example, algorithm took 2 quantities as input. An algorithm must take 0, 1 or more quantities. So, input can also be 0. For example, here I am not writing any input. For example, start. Next, directly I am printing C. Print C and stop. In this, I did not take any input. So, here quantity of input is 0. An algorithm must take 0 or 1 or more quantities as input. Input can be 0, that means there is no need of giving input, but there must be at least one output. An algorithm should produce at least one output. This is first property, and second property is an algorithm should terminate in finite number of steps. That means we need to complete algorithm in countable number of steps. There should not be any infinite steps in algorithm. For example, if you see this example, in this algorithm was terminated in 6 steps which are countable 1, 2, 3, 4, 5, 6. So always algorithm must terminate in finite number of steps, and there should not be infinite number of steps in algorithm. Third point is definiteness. You can also say definiteness as unambiguous. Each step of an algorithm must be clear, means no ambiguity. Means whatever the steps that we are writing in an algorithm, each and every steps must be clearly understandable. There should not be any ambiguity. Ambiguity means mistake. There should not be any mistake. This is known as definiteness. For example, in previous example, I written read a comma b. This step is clear because I am reading two values a, b. But if I written here only read, then it will become ambiguous. Because what should I read? Should I read a or which variable? So it will become ambiguous. Step 4, effectiveness. Effectiveness means algorithm should contain only necessary steps. It should not contain any unnecessary steps. This is known as effectiveness. And at last, fifth one is generality. Whatever the input that we are giving to algorithm, an algorithm should work with our input. This is known as generality. Algorithm should run for any type of input or data. These are the 5 properties or characteristics of algorithm. Next topic is performance analysis of an algorithm, and also I will explain what is time complexity and what is space complexity. An algorithm is said to be efficient and fast if it takes less time to execute and consumes less memory space. Performance of an algorithm is said to be good only if it takes less time to execute and consumes less memory space. So in order to analyze performance of an algorithm, we use time complexity and as well as space complexity. That is, performance of an algorithm depends upon time and as well as space. At first I will explain what is time complexity. The time that an algorithm requires for its execution is known as time complexity. The amount of time that an algorithm requires for its execution is known as time complexity. There are 3 types of time complexities. First one is best case time complexity, second one is worst case time complexity, and third one is average case time complexity. If an algorithm gets executed in short period of time, then it is known as best case time complexity. If an algorithm requires minimum amount of time for its execution, then it is known as best case time complexity. And if an algorithm requires maximum amount of time, that is, if algorithm takes more time for its execution, then it is known as worst case time complexity. And third one is average case time complexity. If an algorithm requires average amount of time for its execution, then it is known as average case time complexity. I will explain best case, worst case and average case time complexities with an example, that is with linear search example. We know what is linear search. Linear search is the process of searching elements one by one until we found key element. In linear search, we will search each and element one by one in order wise until we get our required element, is known as linear search. Here I took example. There are 5 elements, that is 10, 20, 30, 40 and 50. In this I want to find element, that is element number 10. So we will start from first. Here first element is 10. So we got our required element at first. So it is known as best case time complexity. And another example, this is same example. Here I want to find element number 30. We will start searching from first. 30 is not found at first position, so then we will move for second position. Element is 30 element is not present in second position, so again we will move this element one step forward, that is 30. We got our element 30 in third position. It does not took minimum amount of time and it does not took maximum amount of time, so it is known as average case time complexity. And here third example, here I want to find element number 50. At first we will start with first element, that is 10.
50 is not present at first position, so we will move one step forward. 50 is not in second position, again we will move one step forward. In third position element is not found, and in fourth position element is not found. We got element 50 in last position, so time consuming is more. It is known as worst case time complexity because it took maximum amount of time, whereas in first it took minimum amount of time, so it is known as best case, and whereas last one is worst case time complexity. This is an example of time complexity. In order to calculate time complexity, we use two approaches. First one is frequency count. We also call this frequency count as step count, and second one is asymptotic notations. Now I will explain components of time complexity. There are two components of time complexity. First one is capacity of system, and second one is computer containing single processor or multiple processors. I will explain first one, that is capacity of system. Capacity of system depends upon various factors such as RAM, processor, and type of windows that we are using in system, so on. So if speed of computer is fast, then output will be generated fastly, but if speed of computer is slow, then output will get generated slowly. This is known as capacity of system. Second one is computer containing single processor or multiple processors. If computer contain only one processor, that is only single processor, then output is generated slowly, but whereas if computer contains multiple processors, then output is generated fastly. These are the two components of time complexity. Next topic is space complexity. Space complexity is same as time complexity, only difference is that in place of time we need to write space. So definition of the space complexity is amount of space that an algorithm requires for its execution is known as space complexity. Same as time complexity, space complexity is also classified into three types. First one is best case space complexity, second one is average case space complexity, and third one is worst case space complexity. If an algorithm requires less space, that is minimum amount of space for its execution, then it is known as best case space complexity. And if an algorithm requires average amount of space for its execution, then it is known as average case space complexity. And if an algorithm requires more space, that is, and if an algorithm requires maximum amount of space for its execution, then it is known as worst case space complexity.
Next I will explain what is flowchart, and then I will explain flowchart and algorithms for addition of two numbers, average of three numbers, and circumference of a circle. And then I will explain what is branched flowchart with an example. Diagrammatic representation of algorithm is known as flowchart. These are the various symbols that we use in flowchart. First one is ellipse. This ellipse is used to start and stop the algorithm. And next one is rectangle. If you want to write any expression like a plus b, a minus b, so on, we use rectangle. We can write expressions inside rectangle. And next one is parallelogram. In order to read input values like read a comma b and read a b c like that. And similarly, in order to print output, we use parallelogram. This is parallelogram symbol. And next fourth one is rhombus. We can write conditions inside rhombus like a greater than 10, a less than 20 like that. If you want to write any condition, then we need to use rhombus. And last one is arrow marks for flow of solution. This is algorithm and flowchart for addition of two numbers. Step 1 is start. After that, step 2 is read AB. That means I can store two values in variable A and variable B. Let two values be 10 and 20. I am storing value 10 in A and value 20 in B. And step 3 is C is equal to A plus B. Result is stored in variable C. So step 4 is print C. I am printing variable C which contains result, and at last step 5 is stop. This is an algorithm for addition of two numbers. Next, flowchart. Step 1 is start. After that, read A comma B comma C and write C is equal to A plus B. And at last print C because C contains result. So I am printing C, and last step is stop. This is flowchart for addition of two numbers. As I already said before, for start and stop we use ellipse, and for reading values and printing output we use parallelogram. So here I am using parallelogram. And if you want to write any expression like A plus B, A into B like that, we need to use rectangle. So I written C is equal to A plus B in rectangle. Next, this is flowchart for average of three numbers. At first we need to write start in ellipse. After that I am declaring four variables. They are A, B, C and average. After that, read A comma B comma C. That means I am reading 3 values. That means I can store 3 values inside variable A, variable B and variable C. After that, you need to write average is equal to A plus B plus C by 3. In order to calculate average, you need to use this formula. And at last, we need to print average because average contains result. So you need to print average and last step is stop. Reading values and printing output must be written in parallelogram. So I written this both in parallelogram and expressions must be written in rectangle. So here I written expression A plus B plus C by 3 in a rectangle and you need to write start and stop in ellipse. This is flowchart for average of 3 numbers. This is an algorithm and flowchart for circumference of a circle. Circumference formula is 2 pi r. Value of pi is 22 by 7. That means if you convert this in calc, you will get value as 3.14. So first step is start. After that step 2 is read r. After that step 3 is calculate c is equal to 2 into 3.14 into r. This is formula of circumference, that is 2 pi r. So I written here c is equal to 2 into 3.14 into r. After that I am printing c because c contains result. So at last you need to print c and you need to write stop. This is an algorithm for circumference of a circle. Next, this is flowchart. If you write the same algorithm in diagrammatic format, we call it as flowchart. Next, I will explain what is branched flowchart. If we use conditional statements inside our flowchart, then we call it as branched flowchart. This is an example. Here I written start. We need to write start in ellipse. After that, I written grade greater than 75. This is conditional statement. So we need to write this in rhombus. Whenever you use conditional statement in our flowchart, we call it as branched flowchart. If condition is true, then this statement will be executed. If condition is false, then this statement will be executed. For example, if person got 90 marks, 90. So 90 is greater than 75. So I will get output as student has passed. Else, for example, if person got only 60%, then this condition is not satisfied. This statement will be executed. So student has failed in examination. And at last you need to end this. Next topic is
What is linear search and what is binary search? I will explain both example and algorithm, and also I will explain difference between linear search and binary search. At first you need to know what is meaning of searching. Searching means finding our required element from given set of elements. At first I will explain what is linear search. In linear search we will search our required element sequentially, one by one, and if element is found, then we will stop searching. This is an example. Here I need to find element 6. Find element 6. Here total there are 7 elements. Here I given index numbers for each element. As we know, index number starts with 0. Here in index number 0, element is 5. 5 is not equal to 6. So we need to move cursor one position forward. In step 2, I placed cursor to next position, that is in index number 1. In index number 1, element is 2. So 2 is not equal to 6. So again we need to move cursor one position forward. In step 3, I placed cursor at index number 2. In index number 2, element is 3. Again 3 is not equal to 6. Again we need to move cursor one position forward. In next step, cursor is placed at index number 3. Element is 7. 7 is not equal to 6. So again we need to move cursor one position forward. In step 5, we place the cursor at index number 4. Element in index number 4 is 1. 1 is not equal to 6. So again we need to move cursor one position forward. In step 6, I placed cursor at index number 5. In index number 5, element is 6. So here k value is 6. 6 is equal to 6. Therefore, we found our required element. Now we can stop searching, and at last you need to write, therefore, we found element 6 at index number 5. This is an example of linear search. For example, if I want to find element 30, but element 30 is not present in this array. So at that time, we will keep on searching each element, and when cursor reaches to last position, then you need to write element not found. This is an algorithm for linear search. In step 1, we will set k to 0. That means we will place k at index number 0. And in step 2, if array of k equal to required element, then go to step 6. Step 6 is print element found at index number I. Meaning of this is, if k value is equal to our required element, then we will print element found at index number, as you already discussed in before example. Else mean, if k value is not equal to our required element, then set k to k plus 1. That means we will move k one step forward. After that, again go to step 2. After placing k to one step forward, then again we need to check whether k value is equal to our required element or not. And in step 4, if k value is greater than n, then go to step 5. That means we need to write element not found, as I already said in before example. For example, if I want to find element 30, element 30 is greater than these elements. So we need to write element not found, and last step is stop. This is an algorithm of linear search. Next I will explain binary search.
In linear search, in order to find particular element, we need to search each and every element line by line. So it is time taking process. So in order to overcome the limitation of linear search, new searching technique is developed, that is binary search, in order to save time. For example, this is an array of elements. It contains total 6 elements. I want to find element 6. So in linear search, it will search each and every element. First it go to first element. 6 is not present in first. So again it will go to second. 6 is not present in second. Again it will go to third, it will go to fourth, and at last it will go to sixth. Therefore we got sixth element here. In linear search, it will search each and every element in order to find particular element. It is time taking process. So in order to overcome the problem of linear search, binary search algorithm was created in order to save time. Binary search is fast searching algorithm with runtime complexity of O of log n. This is runtime complexity of binary search, and this binary search is based on divide and conquer strategy. In divide and conquer strategy, we will divide problem into sub problems, and then we will solve sub problems, and then at last we will combine these solutions of sub problem into single solution. This is known as divide and conquer strategy. This binary search follows divide and conquer strategy. In binary search technique, we search an element in sorted array. Sorted array is nothing but elements which are arranged from small to big is known as sorted array. This is sorted array. This is example of sorted array because elements are arranged from small to big. That is 1, 2, 3, 4, 5, 6. And we need to find particular element in this sorted array in binary search. For example, here I want to find element 4. We search an element 4 in sorted array. This is example of binary search. I will give one example how to find element in binary search so that you can clearly understand. This is an example of binary search. In this they given list of sorted array. Here they are given total 1, 2, 3, 4, 5, 6, 7. Here there are total 7 elements. In this we need to find element 71, and this binary search is applicable only for sorted array. In order to perform binary search, elements should be arranged from small to big. So here elements are from small to big, so we can perform binary search. At first you need to write elements 11, 24, 55, 60, 71, 77 and 80. Total there are 1, 2, 3, 4, 5, 6, 7. Total there are 7 elements in the array. In this you need to find middle element. Formula to find middle element is lower element plus higher element by 2. This is formula. Lower element is nothing but first element, and higher element is last element in the array. First element in the array is lower element, and last element in the array is higher element. Formula is lower element, that is 1, not 11, 1. 1 plus higher element, that is 7, not 80, 7 by 2, that is 8 by 2. 2 1 ja, 2 4 ja 8, that is 4. So middle element is, value of mid is 4, that is 1, 2, 3, 4. Middle element is 60. Here 71 is the value which we need to find. If value is equal to mid, then our result is true. We can close. That is, we got our result. Here 71 is the value which we need to find. But here mid value is 60. 71 is not equal to 60. 71 is not equal to 60. 71 is greater than 60. So if value is greater than mid, then convert this mid into lower element, because 71 is greater than 60. Elements are already arranged in sorted format. So 60 is smaller element now. So we need to convert it into lower element. Convert this 60 as lower element. Again we need to find mid. Value of mid is lower element plus higher element by 2. Lower element is 4 plus higher element is 7 by 2. That is 11 by 2. That is 2 1 ja, 2 5 point. Don't consider elements which is after point, that is 5. So mid element is 5. Value which we need to find is 71. If value and mid element is 71. Here value is equal to mid. So we found that element. So we found element 71. If value is equal to mid, then we can stop. We got our result. Here mid value is 71. This is how we can search particular element by using binary search. This is one more example. Here I need to find element 24. I need to find 24. So you need to apply formula, that is mid. Formula of mid is lower element plus higher element by 2. Lower element is first element in the array, and higher element is last element in the array. That is 1 plus 7 by 2. That is 8 by 2. 2 1 ja, 2 4 ja 8. 1, 2, 3, 4. Value of mid is 4. So here mid value is 4. Value is not equal to mid. Here value which we need to find is 24. But here mid value we got is 60. 60 is not equal to 24. 24 is less than 60. So in that case, if value is less than mid, then change mid element to higher element, because our element is present in between this. Our element is present in between this 11 and 60. So I changed this mid element as higher element. We should not change this mid element into lower element, because if we change this mid element into lower element, then our element will be present in between this. So here I changed mid element as higher element. You need to remember these two things. If value which we need to find is less than mid, then change mid to high. And if value is greater than mid, then change mid to low. These two things you need to remember. Here value is less than mid, that is 24 is less than 60. So we need to change mid to higher. Again we need to find mid. Formula of mid is lower element plus higher element by 2, that is 1 plus 4 by 2, that is 5 by 2. 2 1 ja, 2 2 ja 4, 0.5. Don't consider element which is after point, so your value is 2. This is mid. Value which we need to find is 24. Mid value is 24. Therefore we got our result. We can stop this. If value is equal to mid, then we successfully searched that element. For example, consider same example, but here I need to find 23. 23 is not present in this array. Here there is 11, 24, 55, but there is no 23 element. In that situation, it will become 23. This is another example. Then in that situation, you need to convert this mid element as higher element. If lower element and higher element comes side by side, then therefore element is not found. We cannot find that element. And in that situation, you can write therefore element is not present. This is another example. This is algorithm for binary search. Step 1. In step 1, we need to find lower element, that is first element in an array, and I am taking this lower element as L, low equal to L, and similarly highest element, that is last element in an array. I am denoting this high as H. After finding lower element and higher element, next we need to apply mid formula. Formula of mid is low plus high by 2. This is formula. After this, you need to go to step 2. Go to step 2. Step 2 is if value is equal to mid, then return mid. We need to return mid. Our result is found. Print element found. Element found at mid. This is value which we need to print. If value is equal to mid, then print element found. Then at last go to step 5. Step 5 is stop. Else, if value is not equal to mid, then there is two chances. That is step 3. That is if value is greater than mid, then change mid to low. As I already said in before example, if value is greater than mid, then change mid to low, and again go to, after changing mid to low, again you need to perform this, again you need to apply this formula. So go to step 1. Else, if step 4, else in step 4, if value is less than mid, then change mid to high. After changing mid to high, again you need to calculate mid value. So again go to step 1, and at last step 5. Step 5 is stop. Here I said now step 5 stop. Else if we do not find that value, then here otherwise, when condition fails, that is we cannot find any element. If condition fails, print element not found. Print element not found and go to step 5, that is stop. This is algorithm for binary search which we need to remember in exams.
Next difference between linear search and binary search. In linear search, there is no need of arranging elements in sorted manner. This is an example. Here I written 5, 1, 2, 3, 4. This is not in sorted manner. In linear search, there is no need of arranging elements in sorted manner in order to find particular element. But in binary search, we need to arrange elements in sorted manner in order to search particular element. This is an example. If you want to find any particular element, then element should be in sorted manner. And next, linear search is based on sequential approach, but whereas binary search is based on divide and conquer strategy. Linear search is suitable for small set data sets, and whereas binary search is suitable for large size data sets. Linear search is suitable only for small size data sets and it is not suitable for large size data sets, whereas binary search is suitable for large size data set. And next difference is worst case complexity of linear search is big O of n and worst case complexity of binary search is O of log base 2n, and best case complexity of linear search is big O of 1 and best case complexity of binary search is big O of 1. Linear search can be implemented on both one dimensional array and as well as multi-dimensional array, but binary search can be implemented only on multi-dimensional array.
Next topic is algorithm to find roots of quadratic equation, and also I will explain algorithms to check number is even or odd and to check number is prime or not, and also I will explain algorithm to find maximum and minimum elements in given list and algorithm for factorial of given number. I will explain algorithm to check number is even or odd. This is an algorithm to check whether number is even or odd. For example, if we divide any number by 2 and if we get remainder as 0, then we consider it as even number, else it is odd number. For example, if you consider number 4, if you divide number 4 by 2, we will get remainder as 0 because 2 2s are 4, so remainder is 0, so 4 is considered as even number. And if you consider number 5, if you divide number 5 by 2, 2 2s are 4 and remainder is 1, so this 5 is not a even number, this 5 is odd number. For every algorithm, step 1 is start and step 2 is read n is nothing but we are reading any number like 5, 4, etc. So here I written read n. And step 3 is if number is divided by 2 and if we get remainder as 0, then print even, else we need to print odd. And step 4 is stop. I will explain algorithm to find factorial of a given number. Before that, you need to know how to find factorial of a number. For example, I want to find factorial of number 3. This is how we find factorial. Factorial of 3 is 3 into 2 into 1. 3 2 are 6 and 6 1 are 6. And similarly, factorial of 4 is 4 into 3 into 2 into 1, that is 24. And factorial of 5 is 5 into 4 into 3 into 2 into 1, that is 120. That means we need to start multiplying from that number to 1. This is how we find factorial of a number. Now I will explain algorithm. Algorithm to find factorial of a number. As we know, for each and every algorithm, step 1 is start. After that, take integer variable a. I am taking variable as a. And then step 2 is assign value to variable. For example, I want to find factorial of 5. So I am giving value of a as 5. And step 3 is for value a to up to 1. That means from starting value a to 1, multiply each digit and store. From this value 5 to till 1, we need to multiply each value and then we need to store this result. And at last, finally, stored value is factorial. This is how we find factorial, and last step is stop. This is algorithm to find factorial of a number. I will explain algorithm to find roots of quadratic equation. These are the formulas to find roots of quadratic equation. That is R1 equal to minus b plus under root of b square minus 4ac by 2a. And similarly, R2 is equal to minus b minus under root of b square minus 4ac by 2a. These are the two formulas that you need to remember in order to find roots of quadratic equation. Now I will write algorithm for this. As we know, step 1 is start. This formula contains a, b, c. So I am reading a comma b comma c values. After that, step 3 is compute d equal to b into b minus 4ac, because this is formula under root of b square minus 4ac. I am storing this b square minus 4ac in one variable, that is d. So here I written compute d equal to b into b minus 4ac. After that, step 4 is if d value is greater than 0, then we can apply these formulas. They are R1 is equal to minus b plus square root d by 2 into a. Square root d is nothing but d contains formula, that is b into b minus 4ac. And similarly, R2 formula is minus b minus square root d by 2 into a. If d value is greater than 0, then we can apply these formulas. But if d value is equal to 0, then we need to compute R1 is equal to minus b by 2a and R2 is equal to minus b by 2a, because value of root 0 is 0. So we cannot apply this formula. Even if you apply this formula, result is same. If d value is less than 0, then you need to write roots are imaginary, and last step is stop. This is an algorithm for finding roots of quadratic equation. Next, I will explain algorithm to check number is prime or not. But before that, you need to know what is prime number. Number which is divisible only by 1 and itself is known as prime number. For example, if you consider number 5, 5 is divisible only by 1 and itself. You need to start from 1 and you need to check till 5. If you divide 5 by 1, remainder is 0. And if you divide 5 by 2, remainder is not 0. And if you divide 5 by 3, remainder is not 0. And if you divide 5 by 4, remainder is not 0. At last, if you divide 5 by 5, then remainder is 0. So this 5 is divisible only by 1 and itself. So this 5 is prime number. And similarly, if you consider number 4, you need to start from 1 and you need to keep on checking till 4. This 4 is divisible by 1 because 1 4 is 4. So remainder is 0. And this 4 is divisible by 2 because 2 2 is 4. So remainder is 0. This 4 is divisible by 2 and this 4 is not divisible by 3 and this 4 is divisible by 4. This 4 is divisible by 1, 2 and 4. So this 4 is not a prime number. Definition of prime number is number which is divisible only by 1 and itself. An algorithm to check whether number is prime or not. As we know, step 1 is start and step 2 is read number n. For example, I want to find factorial of 5. So, I am giving n value as 5. And third step is initialize count to 0 and I to 1. That means we need to start dividing this element 5 from 1 to 5. 1, 2, 3, 4, 5. We need to start from 1 to 5. And initially count is 0. Count is nothing but how many times I got remainder as 0 is known as count. Initially, I am giving count as 0. And step 4 is divide n by I. If remainder is 0, then increment count by 1. Here we given n value as 5. So we need to divide this 5 by 1. We need to start from 1 because here I given I value as 1. So we need to start from 1 and we need to repeat this division until this number 5. So at first I will start with 1. 1 5 is 5, remainder is 0. If remainder is 0, then increment count by 1. So now my count is 1. And similarly take another number 2. Divide this 5 by 2. 2 2 is 4 and remainder is 1. So remainder is not 0. So don't increment count. Keep count as 1 as it is. And similarly take 3. Divide this 5 by 3. 3 1 is 3 and remainder is 2. So remainder is not 0. And similarly take 4. 4 1 is 4. Remainder is 1. Still keep count as 1. And now divide 5 by 5. 5 divided by 5. 5 1 is 5. Remainder is 0. So now increment count as 2. Now my count is 2 because 5 is divisible by 1 and as well as 5. So now my count is 2. Repeat step until I less than n. We start dividing this number n with 1 until n because at first we need to take 1, 2, 3, 4, 5. So we are starting from 1 and we are dividing this number n until n. Repeat step 4. We need to repeat this step until I less than n. I value is 1. Here step 6 is if count is equal to 2 then print n is prime number. Otherwise n is not a prime number. Here count of I is 2. Now we need to print n is prime number. For example, if you give value as 4 then 4 is divisible by 1, 2 and 4. So now count will be 3. Whenever count is 3 then print n is not a prime number. And at last step is stop. This is an algorithm in order to check whether number is prime or not. Next I will explain algorithm to find minimum and maximum elements in given list. They given some array of elements. Now we need to find minimum and maximum element in this array. So initially we need to take this first element as minimum element and maximum element. So now minimum element is 5 and maximum element also 5. Now we need to keep on comparing this element with other elements. Move to next step. Here minimum element is 5 and maximum element is 5. But maximum in highest element. So when compared to 5, highest element is 40. So now replace this 5 with 40 and go to next step. Here minimum element is 5 and maximum element is 40. Okay, minimum is smallest element. When compared to 7, 5 is smaller. And similarly, maximum element means highest element. When compared to 7, 40 is highest. So don't change, keep it as it is and go to next step. Here minimum element is 5 and maximum element is 40. So minimum is smallest element. When compared to 23, 5 is smaller. So keep 5 as it is and maximum element means highest element. When compared to 23, this 40 is highest. So keep it as it is and go to next step. This is also same. Minimum element is 5 and maximum element is 40. And again go to next step. Minimum element is 5 and maximum element is 40. But here minimum element means smallest element. When compared to 90, 5 is smaller. So keep 5 as it is. And maximum element is 40. When compared to 40, highest element is 90. So replace this 40 with 90 and go to next step. Now minimum element is 5 and maximum element is 90. When compared to 51, 5 is smaller. So keep 5 as it is. And when compared to 51, 90 is highest element. So keep 90 as it is and then go to next step. Here minimum element is 5 and maximum element is 90. When compared to 1, 5 is not smaller because when compared to this 5 and 1, 1 is smallest element. So replace this 5 with 1. And when compared to 1, 90 is highest element. So keep 90 as it is. Therefore, minimum element is 1 and maximum element is 90. This is how we find maximum and minimum element in an array. I will explain algorithm for this. Give index numbers for this. 0. Index number starts with 0. 0, 1, 2, 3, 4, 5, 6, 7. These are index numbers. This is an algorithm. Algorithm minimum maximum of a comma n, where a is nothing but array which contain n number of elements. There are n number of elements in an array. So here I written minimum maximum of a comma n. That means we are finding minimum and maximum element in this array. Inside this you need to write max is equal to minimum is equal to a of 0. That means we are considering this first element which is in index number 0 as minimum element and maximum element. So here I written min max is equal to a of 0. For I is equal to 1 to n, that means from starting 1 to till index number 7, you need to apply this. If a of I greater than max, then replace maximum with a of I, as I said before. For example, if you consider this element 40, initially maximum element is 5, but here in a of 1, maximum element is 40. If 40 is greater than 5, then maximum element is equal to a of I. So now we need to replace this 5 with 40. And similarly, if a of I less than minimum, then minimum element is equal to a of I. If you consider this at last, here minimum element is 5 and a of I is nothing but value which is present in index number 7, that is 1. This 1 is less than 5. So we need to replace minimum element as 1. This is an algorithm in order to find maximum and minimum element in given list. At last you need to close these brackets. Next topic is bubble sort, insertion sort and selection sort. I will explain both algorithm and example, and also I will explain difference between insertion sort and selection sort. At first I will explain what is bubble sort. Before that, you need to know what is meaning of sorting. Sorting is the process of arranging elements either in ascending order or descending order. Here they give an array of elements which are not arranged in particular order. So we call it as unsorted array. After arranging these elements in ascending order, that is from small to big, it forms sorted array. Now I will explain what is bubble sort algorithm. Bubble sort is the simplest sorting algorithm that works by repeatedly swapping the adjacent elements if they are in wrong order. I will give one example. Here this is unsorted array where elements are not arranged in proper order. Now we need to sort this array by using bubble sort. We must start from first position and we need to keep on checking whether elements are in proper order or not. First element is 3 and next element is 1. Both are not in proper order because 1 must be first and after 1 there should be 3. Definition of bubble sort is we need to swap adjacent elements if they are in wrong order. So adjacent element of 3 is 1. Now we need to swap this 3 and 1. After swapping, my array look like this. We need to swap 3 and 1. So after performing swapping, my array look like this. 1, 3, 5, 4. Still my array is not sorted because 4 must be here and 5 must be here. So again we need to swap these adjacent elements. After performing swapping, my array look like this. 3, swap 4 and 5. Now my array is in sorted manner. This is how we sort elements by using bubble sort. This is an unsorted array. Now we need to sort this array by using bubble sort. We should start from first element and then we should keep on checking each and every element whether these elements are in correct position or not. So write same as it is. 5, 1, 4, 2 and 8. Now place cursor to first position. First element is 5 and next move cursor to next position. Next element is 1. These both are not in proper order because 1 must be first and after 1 there should be 5. So these both are in wrong order. So swap this adjacent elements. Adjacent element of 5 is 1. So we will swap this both. 1, 5, 4, 2 and 8. My cursor is here. Now move cursor 1 position forward. So I am placing cursor here. Here is 5 and 4 both are in wrong position because 4 should be first and after 4 there should be 5. So again swap this both adjacent elements. So after swapping, my array look like this. 1, 4, 5, 2, 8. My cursor is here. Now move cursor 1 position forward and compare this both. 5 and 2. 2 should be first and after 2 there should be 5. So again swap this 5 and 2. Swap this adjacent elements. So after swapping, my array look like this. 1, 4, 2, 5, 8. Now my cursor is here and move cursor to next position. So my cursor reach to last position. 5 and 8 both are in correct order. So there is no need of swapping. Here cursor reached to last position, but elements are not in proper order. That is, still it is unsorted array. So consider it as first pass and we need to start second pass. And again we should keep on sorting the elements. This is second pass. Write these elements here. 1, 4, 2, 5, 8. 1, 4, 2, 5, 8. Again we should start sorting from first. Move cursor to next position. 1 and 4 both are in correct order. So again move cursor to third position. Here 2 should be here and 4 should be here. So exchange these both adjacent elements. After sorting, my array look like this. 1, 2, 4, 5 and 8. Now all these elements are in ascending order, that is from small to big. So we can stop sorting. Now this is considered as sorted array because all these elements are in proper order. Sorted array. This is how we perform sorting by using bubble sort. Guys, roughly I explained, but you need to write this in step by step manner like this. Actually, after performing swapping, my cursor is here. So you need to perform checking until last element. So again move cursor here and again take another step. 1, 2, 4, 5, 8. From 8 you need to move cursor here. Whenever this cursor is reached to last position, then you need to check these elements whether these elements are in correct position or not. This is how we perform bubble sort. I will explain algorithm of bubble sort. This is an algorithm for bubble sort. Step 1 is start bubble sort of array because we are performing bubble sort on array of elements. So here step 1 is start bubble sort array, and next step is if array I is greater than array I plus 1, swap array I comma array I plus 1. That means if first element is greater than next element, then we need to swap this both elements. This is meaning of this step. If you consider this example, here first element is 5 and next element is 1. This 5 is greater than 1 because actually 1 should be first and after 1 there should be 5. These both are in wrong position. So we need to interchange these both elements. We need to perform this step for all the elements present in an array. We need to close this if condition. So step 4 is end if, and after that we need to close this for loop. So step 5 is end for. After that we need to return array, and at last we need to end bubble sort. This is the algorithm for bubble sort. So you need to remember definition of bubble sort, that is we swap adjacent elements if they are in wrong position. Next I will explain what is selection sort. This selection sort algorithm sorts an array by repeatedly finding the minimum element from unsorted part and then putting it at the beginning. This selection sort maintains two arrays. One is sorted array and one is unsorted array. I will give one example so that you can clearly understand how selection sort will work. This is unsorted array. Now we need to sort this array by using selection sort. Selection sort maintains two arrays. One is sorted array and one is unsorted array. So let us consider this as unsorted array because this is not in proper order. So consider it as unsorted array. Selection sort will find minimum element in an array and then it will place this minimum element at the beginning. So minimum element is 2. So 7, 5, 4, 2. Minimum element is 2. So it will keep this 2 at the beginning and move this 7 in place of 2. So 2, 5, 4, 7. Selection sort will find minimum element in an array and it will place this minimum element at the beginning. So after placing minimum element at the beginning, it will consider it as sorted array. So consider this 2 as sorted array, sorted, and consider this remaining 3 as unsorted array. 5, 4, 7. Now again we need to find minimum element from this unsorted array. Minimum element from this unsorted array is 4. So we need to place this 4 at the beginning. So I'm placing this 4 at the beginning and place this 5 in place of 4. 2, 4, 5 and 7. After placing minimum element at the beginning, consider this 4 as sorted array. So we need to write 2, 4. This is sorted array and this is unsorted array. Now again we need to find minimum element from this unsorted array. Minimum element is 5. 5 is already at beginning, so consider it as sorted array. So 2, 4, 5 and it lost 7. This is sorted array and this is unsorted array. This 7 is at the beginning, so again move this 7 into this sorted array. All these elements are from small to big, so this is sorted array. This is how we perform sorting by using selection sort. Next I will explain algorithm for selection sort. Here step 1 is start and step 2 is selection sort of array because we are sorting array of elements. So I written here selection sort of array, and step 3 is for all array elements, search minimum element and swap element at the beginning and consider it as sorted element. As I already explained in this before example, here smallest element is 2. We will bring 2 at the beginning, and then we will maintain these two as sorted array, and we need to maintain this process until complete list is sorted. So fifth step is increment minimum to next point and repeat until list is sorted. This is an algorithm for selection sort. The selection sort and bubble sort is not suitable for large size data sets. It is suitable only for small size data sets. Next I will explain what is insertion sort. Insertion sort is simple sorting algorithm that works similar to the way you sort playing cards in your hands. This insertion sort works same like how you sort playing cards in your hands. This is unsorted array. Now we need to sort this array by using insertion sort. At first you need to place cursor at first position. After that move cursor to next position 7, 3, 5, 4, 2. Move cursor to next position. This insertion sort works same like playing cards. That means this 3 is compared with 7 and this 5 is compared with 3 and 7. 4 is compared with 5, 3, 7 and at last 2 is compared with all these remaining elements. Based on this you need to perform sorting. So whenever you move cursor to element 3, 3 must be here and 7 must be here. So you need to write like 3, 7, 5, 4, 2. Move this cursor next position, that is here. Now again compare this 5 with remaining these two elements and arrange these elements in sorted manner. 3, 5, 7, 4, 2. 7, 4, 2. Now again move cursor to one position forward, that is 4. Place cursor at element 4. Now compare this 4 with remaining elements, that is 3, 5, 7. Actually 4 should be placed in between 3 and 5. So arrange this in sorted manner like 3, 4, 5, 7 and 2. At last move cursor one position forward, that is in place of 2. Now 2 is compared with all these remaining elements, that is 3, 4, 5, 7. Actually 2 must be at starting position. So arrange this in sorted manner like 2, 3, 4, 5, 7. Now this is sorted array. Now all these elements are from small to big. Now I will explain algorithm for insertion sort. Here step 1 is start and step 2 is insertion sort of array comma n. That means we are performing insertion sort on n number of elements in an array. And step 3 is from I equal to 1 to n minus 1, that is from starting element to ending element. Pick element array of I. That means we need to pick particular element and then we need to insert that element in sorted sequence, that is like 1, 0, 1, 2, 3, so on I minus 1. And last step is stop. Next I will explain difference between insertion sort and selection sort. Definition of insertion sort. Insertion sort is a simple sorting algorithm that builds the final sorted list by transferring one element at a time. And this is definition of selection sort. Selection sort is a simple sorting algorithm that repeatedly searches remaining items to find smallest element and moves it to the correct location. It transfers an element at a time to the partially sorted array, and in selection sort it finds least element and move it accordingly. Insertion sort is more efficient when compared to selection sort, and selection sort is less efficient when compared to insertion sort. Insertion sort is complex than selection sort, and whereas selection sort is simple when compared to insertion sort. Insertion sort is more complex than selection sort, and whereas selection sort is very simple when compared to insertion sort. Best case time complexity of insertion sort is big O of n, and average and worst case time complexity of insertion sort is big O of n square. And whereas best case, average case and worst case time complexity of selection sort is big O of n square. Worst case space complexity of insertion sort is big O of 1, and whereas worst case space complexity of selection sort is big O of 1.
Next topic is various complexities of sorting algorithms, and also I will explain what is divide and conquer strategy and asymptotic notations. At first I will explain various complexities of sorting algorithms. Complexities are classified into two types. One is time complexity and another one is space complexity. Time complexity means amount of time that an algorithm required to complete its task is known as time complexity, and similarly amount of space that an algorithm required is known as space complexity. These are various algorithms and their time complexities and space complexities. We call it as big O, and we call it as theta, and we call it as omega. You need to remember this. Best case time complexity of bubble sort is omega of n, and whereas average case time complexity of bubble sort is theta of n to the power of 2, and similarly worst case time complexity of bubble sort is big O n to the power of 2, and similarly worst case space complexity of bubble sort is big O of 1. Similarly best case time complexity of selection sort is omega n to the power of 2, and similarly best case time complexity of insertion sort is omega of n. Guys, this table is very easy to remember. For all these three sorting algorithms, average case time complexity, worst case time complexity and worst case space complexity is same. Just you need to remember these three. Best case time complexity of linear search and binary search is big O of 1, and best case time complexity and worst case space complexity of linear search and binary search is big O of 1, and average case and worst case time complexity of linear search is big O of n, and average case worst case time complexity of binary search is big O of log n. This is important question, you need to remember this table. Next topic is divide and conquer strategy. What is meaning of strategy? Meaning of strategy is nothing but it is an approach or design to solve a particular problem is known as strategy. For example, if there is a problem, in divide and conquer strategy, we will break down this problem into multiple sub problems. For example, this is large problem. I am breaking this large problem into multiple small problems P3, P4 and Pn, and we need to find solution to this each sub problem. This is solution 1, solution 2, solution 3, solution 4, so on, solution n, and at last we need to combine all these solutions of sub problems into single solution. This is known as divide and conquer strategy. In divide and conquer strategy, we divide single large problem, this is single large problem, into multiple small sub problems. This large problem is divided into smaller sub problems, and then find solution to each sub problem, and then we are finding solution to each sub problem, and at last we need to combine all these solutions to get solution to main problem. This is known as divide and conquer strategy. Now I will write algorithm for this divide and conquer strategy. Divide and conquer strategy of problem. If problem is small, then we can write solution directly. Meaning of this is, if problem is small, then we can write solution of this problem directly. Else, if problem is large, then divide problem into multiple sub problems, that is P1, P2, P3, so on, Pn. Apply divide and conquer strategy to P1, subproblem P1, divide and conquer strategy to subproblem P2, so on, divide and conquer strategy of Pn. And similarly after that, after finding solution to these subproblems, we need to combine all the solutions of these subproblems. Combine divide and conquer strategy of P1, that is subproblem P1, P2, so on of Pn. Here close this, and at last close this. This is algorithm for divide and conquer strategy. Next topic is asymptotic notations. By using asymptotic notations, we can calculate time complexity of an algorithm. Time complexity means amount of time taken in order to execute an algorithm is known as time complexity. By using asymptotic notation, we can calculate best case time complexity, average case time complexity and worst case time complexity of an algorithm. I already explained what is best case, average case and worst case in previous example, that is in linear search example. If we found an element in first position, then time taken is less, so it is known as best case time complexity. And if element is found in last position, then time taken is more, so it is known as worst case time complexity. And if element is found in between first and last element, then it is known as average case time complexity. Asymptotic notations are classified into 5 types. First one is big O notation. It is denoted by capital O symbol. Second one is big omega notation. Third one is theta notation. Fourth one is little o notation, and at last fifth one is omega notation. I will explain each and every notations in detail. First one is big O notation. It is denoted by capital O symbol. Big O notation is mainly used to represent upper bound of an algorithm's runtime. It is mainly used to represent upper bound of an algorithm. And by using big O notation, we can calculate worst case time complexity of an algorithm. Worst case time complexity mean algorithm which takes maximum time for execution is known as worst case time complexity. So by using big O notations, we can calculate maximum amount of time taken by an algorithm for execution. This is known as big O notation. Main use is to calculate worst case time complexity. This is definition of big O notation. Let f of n comma g of n be two non-negative functions. Non-negative is nothing but positive functions. Let f of n, that is function f of n and function g of n, these both are two non-negative functions, then f of n is equal to O into g of n. Here I took O because big O notation is denoted by capital O symbol. So I took here f of n equal to O into g of n. If there exist two positive constants, that is c and n naught, these both are two positive constants such that f of n less than or equal to c into g of n for every n greater than n naught. Meaning of this is, condition f of n equal to O into g of n is satisfied if f of n less than or equal to c into g of n for every n greater than n naught. Again I will explain this definition. Let f of n comma g of n be two non-negative functions, then f of n is equal to O into g of n if there exist two positive constants, that is c and n naught, such that f of n less than or equal to c into g of n for every n greater than n naught. This is graphical representation of big O notations. This is graph in which x-axis represents number of elements, that is denoted by small n symbol, and y-axis represents time, it is denoted by small t symbol. From center there are two lines passing. First line is c into g of n, and whereas second line is f of n. C into g of n should be in upper position because I already explained big O notation is mainly used to represent upper bound of an algorithm. So c into g of n should be in upper position, and whereas f of n should be below c into g of n, that is in lower position. And point at which these two lines meet is known as n naught, where n is greater than n naught. Next I will explain big omega notation. If you understand this big O notation, remaining all these notations are very easy to understand because all are same as big O notation, only some small changes. Now let me explain big omega notation. Big omega notation is mainly used to represent lower bound of an algorithm runtime, whereas big O notation is used to represent upper bound of an algorithm. But big omega notation is used to represent lower bound of an algorithm, and by using big omega notation we can calculate best case time complexity of an algorithm. Best case time complexity means minimum amount of time that an algorithm requires for execution is known as best case time complexity, and by using big omega notation we can calculate minimum amount of time that an algorithm requires for execution. Whereas big O notation is used to calculate worst case time complexity, but big omega notation is used to calculate best case time complexity. This is definition of big omega notation. Let f of n and g of n be two non-negative functions, then f of n equal to omega of g of n. Here I took omega because this is big omega notation. If there exist two positive constants c and n naught such that f of n is greater than or equal to c into g of n for every n greater than n naught. This definition is same as big O notation, only difference is that here in place of O we used omega, and in place of less than or equal to we used greater than or equal to. Only these two difference. Here f of n is greater than or equal to c into g of n because here we are calculating best case time complexity, because big omega notation is used to calculate best case time complexity. So f of n is greater than or equal to c into g of n for every n greater than n naught. This is graphical representation of big omega notation. Here I took graph in which x-axis represents number of elements and y-axis represent time, and there are two lines passing from center. First line is f of n, and whereas second line is c into g of n. Here c into g of n represent lower direction because big omega notation is mainly used to represent lower bound of an algorithm. So c into g of n is lower to f of n, whereas in big O notation I took c into g of n upward because it is used to represent upper bound, whereas in big omega notation it represents lower bound. So I took c into g of n lower to f of n, and point at which these two lines meet is known as n naught, where n is greater than n naught. Third one is theta notation. Theta notation is mainly used to represent average bound of an algorithm, and by using theta notation we can calculate average case time complexity. Average case time complexity mean average amount of time that an algorithm requires for execution is known as average case time complexity. By using theta notation, we can calculate average case time complexity of an algorithm. This is definition of theta notation. Let f of n comma g of n be two non-negative functions, then f of n equal to theta of g of n. If there exist three positive constants, they are c1, c2 and n0, such that c1 into g of n less than or equal to f of n less than or equal to c2 into g of n for every n greater than n0. This is definition of theta notation. Whereas in big O and big omega notations there are only two constants, that is c and n0, but whereas in theta notation there are three positive constants, they are c1, c2 and n0. This is graphical representation of theta notation, where there are three lines passing from center, where c1 into g of n less than or equal to f of n, that is lower bound, and whereas if you close this, f of n less than or equal to c2 into g of n, which is an upper bound, and where f of n is placed in between this. Next, little o notation. There is no example and graphical representation of little o notation. There is only definition. Definition is, let f of n comma g of n be two non-negative functions, then f of n equal to small o of g of n, because it is little o notation, such that limit n tends to infinity, f of n by g of n equal to 0. This is little o notation. And next, fifth one is little omega notation. Definition is same as little o notation. Difference is that here limit n tends to infinity, g of n by f of n equal to 0.